So today is week 12. It's our last lesson of our kind of shortened semester. So what are we going to do this week? I'm just going to go over the final exam requirements one more time. Well, that's good, Liam. I'm glad to hear that it's been good. I know it has been challenging, and probably everyone would prefer to be on campus where we can be together. But, you know, if the semester's gone well for you, despite that, I'm certainly glad to hear that. So I want to talk about the final exam. I did talk a bit about it last week, but I will just go over it one more time. I'm going to give you assignment 2, part 3. Yes, I know you have lots of assignments. This one is super short. You don't even actually have to write one line of code. So it's like 5 free %. We'll go over it after I talk about the exam. And my suggestion with assignment 2, part 3, we're going to have a short lesson today. We should be done by 12:30. So my suggestion is do the assignment immediately after the lesson, submit it, get it done. There's no need to wait to do it. Just do it and get it done today. It's 5 super easy %, and then I can mark it quickly. And then we're going to look at building an API with ASP.NET Core. So we're going to look at some basic terminology. We're not going to, as I said, we're not going to really write any code of our own. We're just going to check out the scaffolding tools for developing an API in .NET, and we're going to use Postman to test it out, which is a free tool. We're also going to look at the tools for documenting an API that come with Visual Studio. So final exam. So next week, I'll be sure to open the WebEx room early, 10:45 or sorry, 10:45 by 10:50. Absolutely, the WebEx room will be open. So make sure you sign into WebEx at that time. Okay, the exam will start at 11, and you have to submit by 2 p.m. Okay, you do not need to use Azure for the exam, but you do need to use GitHub. So what you can actually do, you can go ahead this week, you can make a new private repository for your exam, and you can add me. You can do that ahead of time. So you already have that repository set up. Okay. One of the things I'm going to ask you to do is I'm going to ask you to make a commit to your GitHub repository during the exam every 30 minutes. And there's a couple reasons for this. One, so if something happens to your computer, you're not going to lose all your work during the exam. 2, at the end of the exam, you won't be struggling to create a repository and upload because you will have already uploaded most of your work to GitHub long before the end of the exam. And 3, there's a bit of an honor system here. You know, you guys are working from home. We're not using any sort of proctoring system. So the fact that you're committing regularly shows me your progress and how you're working on it. So that helps me verify that you are in fact submitting your own work. So you are free to go ahead and create that repository ahead of time. I'm going to provide you with this, and make sure when you create the repository, create it as empty. Don't put a README file in it or anything at all. Okay. So during the exam, I'm going to provide you with a new .NET Core web application. It will already be connected to a shared database. You're not going to have to change the database at all. And then I'm going to have a bunch of requirements. Basically, we're going to take our video game store, our Get Me a Game store, and I'm going to ask you to add some new features to that. And some things will be really easy. Some things will be more advanced. Obviously, the easy things are worth less marks than the more advanced tasks. The exam will be randomized, so not everybody is going to get the same exact list of requirements. And again, this is helping me to verify that you're doing the work on your own. A little harder to verify if I give everybody the exact same exam to do. I know this is a great group of students, and yes, I trust you, but at the same time, I have to do my due diligence and ensure that I'm getting everybody's own work. Are there any questions? And you do have to submit by 2 o'clock. So when it says 11 to 2, that doesn't mean you can enter the exam room and start the exam at 1:50 and you get 3 hours. Okay, great questions. Tips and tricks. So how to study. I can suggest 2 things. The first one is if there were things in the in-class lessons from the Get Me a Game store that you didn't understand and things you couldn't get working, then practice by cleaning up your Get Me a Game store now. So that would be, and again, you can use the videos and my GitHub repository as a guide, but see if you can actually write the code to fix those things up yourself using those resources. Suggestion number 2 is take your assignment 2 and do an honest assessment with the final product. You know, is it ready for publication? Like if, does all the UI make sense? Are there any features there that would make sense to be there that aren't there? For example, like, you know, should data be sorted alphabetically? Should things be formatted in a different way? Should you change the authentication rules? So take an honest look at your own assignment and see what else, you know, if I was going to launch this as a real world website and maybe even have someone pay me for it, what other things would somebody likely want in here? So take your assignment and make it better. That's kind of a good way to practice. So here's what's going to happen. So I'm going to have a big list of requirements, and each student is randomly going to be given a subset. So if there's 30 requirements in the assignment, you, yourself, you might be asked to do, let's say, 6 of them. Okay. You can do those 6 in any order you like, but the 6 requirements you're going to do may not be the same as the requirements someone else is doing. Okay, in terms of what order you do them in, that's entirely up to you. Yeah, Maggie, I'm not going to ask you to do things I haven't taught you, but I am going to ask you to adapt the things I've taught you and implement them in a different way. Okay, so that shows me you're learning. You know, step 1 is what we do in class. We walk through things together, you know, and we do together. But I may then ask you to take some of those things and do something else with it, for example. Okay. I can tell you right now, in terms of content, the Stripe payment is not going to be on the exam at all. That was a nice to know feature. It was not a required learning outcome of the course. I am not testing you on it. So I'm not going to ask you to modify or do anything else as far as Stripe payment goes. But being able to add, edit, delete, and read data from your database, I may ask you to do those things in a different way. Like I may say, build a page that shows this data, for example. Anything around authentication, I could ask you to do. There will be definitely, you'll have to write at least 1 unit test. That'll be part of it. As well potentially as working with Web API that we're going to do today. So really anything we've done during the course of our lessons other than Stripe is fair play for the exam. Normally my final exams focused more on the second half of the course, but that's because we do a midterm to test the first 6 weeks of lessons. We didn't have a midterm, so really anything we've covered in the whole course is fair. And there may also be a little bit of debugging skills. I might put a couple of errors in there that you will have to fix in order for things to run properly. You will also not have to use Azure at all. So you do not have to deploy the site to Azure. Don't worry about that. Right, Diana, that's going to be requirement 1, worth 1 mark. You know, like, so for example, just to kind of give you a little more context. So, you know, think about what kinds of features a regular shopping cart has, like go to a website like, you know, Indigo or Canadian Tire, and look at the shopping cart. What kinds of features are commonly there? So something I might ask you to do is maybe build a page where a user can shop by price, right? We know how to read data. We know how to write a query with a filter on it. So that's the kind of thing I might ask you to do. Okay, so you're taking what we've done. You have the skills to do it. We've just never built that exact page. So we've built pages that show a list of products, but it's filtered by a category. So I might ask you to build a page that shows a list of products with some other kind of filter instead. Okay, I'm not seeing any other questions. Just before we... Justin, that's a question for another day. Good question, but I'm not going to go into that right now. Just a little bit too off topic for the moment. Happy to talk about that with you offline if you'd like. Just before we look at assignment 2, part 3, for those of you who, I know it's not everybody in this class, but most of you, for those of you who are in the web program, I have a preliminary schedule for us for next semester. It's not finalized. We have 2 classes together next semester. So, and it looks like right now our advanced server-side scripting class, where we're going to learn how to use Node.js, MongoDB, and Angular. Right now, that looks like it's going to be Thursdays at 11 o'clock. And then our other class is our Web Project Studio class. Right now, that looks like it's scheduled for Mondays. I don't have a time yet. I'm really hoping it does not get scheduled at 8 a.m. But if it does, that class, we really don't need 3 hours. So if they schedule us for a block from 8 to 11, we would not start before 9 o'clock. There'd be no need to start that class at 8. So those schedules aren't finalized yet. And I realize some of you are in the programmer stream, in which case this is our last course together. But then unless you do your 3rd year, and I'll have you back for Android next September. Okay, so that is to be finalized, but it's looking like Mondays, probably 9 a.m., and Thursdays, probably 11 a.m. Justin, the amount of sympathy I have is very low. And I have the Project Studio class was scheduled for 8 o'clock on Thursdays. And I went to our scheduler and said, there's no way you can ask students to listen to my voice remotely for 6 hours in one day. So please move one of these courses. So she did. She did move the Project Studio to was able to move to move Project Studio to Mondays. Again, I haven't had the time confirmed, but it's probably going to be in the morning. So if they schedule it for 8, we'll just start later and make sure we stick to a 2-hour lesson. Yeah, well, you may have to shuffle that around a little bit. I know, it's nice to be young. Okay, so I want to dive into assignment 2, part 3. As I said, just do it today as soon as we're done class. Honestly, that's the best thing. So here's what you have to do for it. Okay, it's only 5% of your grade. It is due Sunday. It should take like 10 minutes. All you need to do is give me your repository link. I don't even really need the Azure link. Okay, if you have it running on Azure, that's great. That will let me mark it faster. If you don't, it's no problem. So you can use the same repository, same Azure link. Okay. This stuff shouldn't apply because you're scaffolding the code, really. The scaffold is just going to run. So what do you need to do? Excuse me. In your existing assignment project, under controllers, this should say your controllers, called API, you're going to scaffold one API controller for one of the tables in your database. You don't have to do both of them. I'll just say use GitHub to make a commit. You only need one commit, is fine. If you can publish to Azure, great. if you do any bonus features, which probably no one has time to do, doing anything advanced with .NET Core Web API, that's fine. And make sure you list it in the README file. Okay, so you're basically just scaffolding a controller, and that's pretty much it, committing it to GitHub. So the assignment is super simple. Everybody should be getting 5 full percent for this assignment. I'll just update the document here with that requirement. You only need one commit. Well, Diana, that's up to you. Something that would show independent learning by extending the functionality of using Web API. So I'm not going to tell you what it would be. I guess if you want a simple example, something like securing your API with JWT, with a JSON Web Token. If you taught yourself how to do that and included that, you could get bonus mark for that. Okay, so here's our first activity for today. Before we start into Web API, we've got some important terminology in the Lesson 12 folder here. So I'm going to give you 5 minutes, and depending on which group you're in, so it'll be the same groups, you can find your group here on Blackboard, but the same groups we've worked in before. If you're in group 1, I want you to come up with a simple definition of, and I want you to use everyday language, not technical language. What is an API? If you're in group 2, I want you to define the term REST. If you're in group 3, your term is put. If you're in group 4, your term is URI. And group 5, I want you to find and explain HTTP status code 400. Just make a note on your own machine for now. And in 5 minutes at 11:23, I will ask each group if they can share what they found, and then I'll add all the definitions to Blackboard. Okay, so you've got 5 minutes. I'm going to pause the screen share in the recording. Just make a note on your own computer, and we'll share notes at 11:23. Okay, so we are back, and our time's up. So I'm going to ask group 1. So if you were in group 1, you can use the chat. Tell me, what did you find if we were going to define an API for the rest of the class? So please add your definition. All right, these are great. Thank you, Justin and Emily. And Stephen, all right, these are good definitions. I'm going to add all of them. All right, so the term is application programming interface, and it's all about interaction between different devices and software applications, right? So the API defines how they can interact, how we make those calls and what formats to use, okay? So it's an intermediary allowing two applications to talk to each other. As Stephen said, it defines what and how software is. Emily is right. So when we use an app like Facebook, we are using one of their APIs. Okay, Diana, did you want to show us a quick example if you like? You could do that.
Yeah, sure. I'm just building for the JavaScript website.
Okay.
So I have a back end and a front end. A second, and I think it's just very cool to see using Postman. This is the
Yep,
web
which is what we're
API.
going to do.
Really. Uh, yeah, so basically, like you specify your API call. So, for example, I have API if you want questions running on the backend.
Yep.
And this gets you the body, or you can pose this. It's basically talking between two projects, this
Right.
one and this one,
Great.
front end and back end.
Great. Thank you for sharing.
Sure.
And we've actually used several APIs in our Get Me a Game project. What are some of the APIs that we've used so far this semester? Um, the database isn't quite an API. It is an external component, but that one works a little different. That's okay. It's a good guess. Yes, so the Google login was one, right? We used Google's API to authenticate users. What other APIs have we integrated into our application? Yep, Stripe for payment, right? We're not processing the payment ourselves. We're using Stripe's definition, right? And we send a request to Stripe following their format, and it sends us back a payment response. Yeah, and all of the logins. So yeah, when we did the Microsoft login as well. So all of those are APIs. We're using external services to add new functionality, extra functionality into our application. Okay, great answers. Thank you, everybody. Okay, what about group two? What is REST? 2 weeks, Liam. 2 weeks. Okay, so it's an architectural pattern for APIs. Yep. It allows us to edit and add new resources. The web server will transfer the client to a representation of the state. Yep, so it stands for representational state transfer. And yeah, Ivan, this is a good point as well. So REST defines how the API is designed. So it's a kind of a standard format for APIs, and it does use less bandwidth. So there's kind of certain standards. Let's actually look here. So if we look at documentation, yes, I spelled Spotify wrong. So Spotify's got an API, and in their documentation, right, it defines requests, and typically, it says it's based on REST principles. So where possible, our methods use one of these: get, post, put, or delete. So most REST APIs, they'll follow this pattern, this structure. We'll see what this means in a little more detail in a minute. Okay, good answers. Thank you, Hung and Ivan. How about group three? So what does put mean in the context of REST? You got it, Maggie. And so young. Okay. So we use put for doing an update. It replaces the resource in its entirety. And as So Young said, it's basically used for doing an edit. So far, we've only ever really used get and post methods. Right. Farouk, I'm going to add your comments as well. So we don't use put when we're adding. We use it for editing, and we can see that here on Spotify. So get is going to run a select query. Post is going to run an insert. Put replaces or changes existing resources. Delete obviously does delete. So any API where we're doing an update, we're going to use put as the method. Okay, excellent answers. Thank you. How about group 4? What is a URI? Okay, Janelle, that is a great answer. Thank you. It's a uniform resource identifier. It's a string of unique of a unique address. It identifies an abstract or a resource, but this is also an important point. All URLs are URIs, but all URIs are not necessarily URLs. Can anybody kind of explain the difference? So what's the distinction then between a URI and a URL? We said every URL, Uniform Resource Locator, is an example of a URI. Right, so on a web page, yes, so URI could be something other than a web page, right? So a URL, it's an example of a URI. So we can't have in a browser, right? We can't have two different two URLs that are exact same that point to two different places. Every URL is unique. But a URI is not only used for web addresses. So as Farouk mentioned, so it can be an HTTP address, which is a URL, but it could also be a DB connection, FTP address, mail server address, yeah, it can also be a file path. So for example, on your mobile device, right? When you take a photo with your device, it stores that photo, that resource on your phone and it uses a URI, the path to it, but so it's unique, but it's only unique to the device. And that path is not going to start with HTTP. It's not going to look like a web address. It's still a URI, but it's not a URL. And right, that's an important point, Maggie, right? So URIs are named with nouns as opposed to verbs. So in REST, the methods are verbs. Get, post, put, and delete. They suggest an action. We're doing something with resources. In URIs, they're nouns because they are objects, so to speak. We can see again here in Spotify, right? It's talking about URIs. So the URI would be the link to, for example, so here in Spotify, this is a URI, but it's not a URL. It's not a web address, but it's a specific resource within the Spotify application. Okay. Good answers. Thank you. And group 5. This. What is HTTP status code 400? So when we're working with APIs, we're going to get into seeing some new HTTP status codes. So far, the only ones we ever really see are 200, which is okay, and 404 not found. What about HTTP status code 400? Anybody in group 5 that can tell us what this means? Nope. Good guess, Farouk. Was there anybody in class today live who's in group 5 and looked up this one? Thank you, Aggie. Status code 400 is bad request. So the server cannot understand or make sense of the request properly. No, a 404 means something different. 404 means the request is valid, the server understands it, but the resource the user is asking for doesn't exist. So it's not exactly, it could be page unknown, but it's not necessarily a page. So for example, it could also be an image. So if we request an image or a media file that doesn't exist, we're going to get a 404. It's any request. So in 404, the request is understood, but the resource that the user is asking for can't be found. 400 means the server can't make sense of the request at all. Okay. So here's a great guide. No, it's even before. It's not an error processing the request. It's the server can't even process it. It can't make sense of the request. So I'll show you an example. Let's open up our Get Me a Game store, and we'll find an example of something that might bring about a 400 response. Yes, that's right, Emily. That's a better example. Okay. Like bench. Yeah, Maggie, that could be. So this site here shows all the various HTTP statuses. So we're going to look at some of these. So 200 is okay. 201 would typically be when we're posting new data. So we're calling a REST API and we're using a post method which creates new data. Typically, rather than sending back an OK response, it should send back a 201 response, meaning a new resource was created. So in the 400s, we can see, right? So 404 is the one we're familiar with, not found. You've probably occasionally seen unauthorized or forbidden. So bad request. So usually there's a syntax issue in here. I love this one. This is error code 418 that says I'm a teapot. So let me just run my store and we'll see if we can generate a bad request. So I'll go to shop. So here, this is returning a 200 response. I'll just open up my web console so we can check it. That work, right? So when I load this page right now, I get a 200 OK response. If I change this to ABC, I pass a string parameter to the browse method instead. Okay, wasn't expecting that. Let's see what happens. Okay, it did give me an error. See if I can actually generate a bad request if I mess through the URL. On this case, I get 404. Okay, I haven't been able to generate one quite yet. That's okay. We will generate one when we build our API. So if our API method asks for something and that parameter is not provided properly, it's going to generate, our API is going to generate a 400 response. So I'll just save those. Okay, so let's try and create a quick API. Just before we do, we need a tool, which I've put linked to on Blackboard, which I want you to download and install. It's a free tool called Postman. So you can get it from getpostman.com. So go here. I'm not sure if you need an account to download it. You might. So we want the API client. Yeah, I think you do just have to create a free account to download it. So Diana already showed it to us. It's free. So what this allows us to do is to call any API. We can call the methods and inspect. We can make calls to the API and see what we get back. So I'll show you how this works, and then we're going to try making our own API. So I can actually try Spotify's API. I'm going to open up Postman. I'm just going to show you how it works. I know you need a few minutes to install it. No problem. Maybe just let me know in the chat when it's installed. So you get a screen like this. And then there's a little form at the top. On the left, there's a drop down where we can choose the REST method we want to call, get, post, put. We won't worry about the other ones, delete. And then there's a URL. And then we can send our API request. So there's actually an example right here on Spotify. I'm going to copy this URL. I'm going to try the Spotify sample API. So I've put the link in the chat if you want to try it. So I'm going to leave the method as get, which is the, so let's close this. I'll open a tab. I'm going to paste in the URL to the Spotify API. So this is their artists API. So it's got an ID of some artist, and then it's returning the albums, where the album type is single, saying I want 10 albums. So when I call the API, I get back a 401 unauthorized response. So it's saying I'm not authentic. I want some sort of authentication from me. I didn't provide some kind of authentication token. So we can use this to call any API. I'll just here's another sample one. This is the JSON placeholder. It's a fake API. So I'll try this. I can call get to download Postman. You have to sign up first. You have to create a free account and then you can download. So I'll try this URL in Postman instead. Doesn't require authentication. So when I call the get to-dos, it gives me a JSON object with some fake data. And every element in here has an ID. Thank you, Diana. The link's in the chat. So it's just postman.com/downloads. And it's the API client program we want. So when I make a get call to /todos, this gives me all the data in the to-dos table. If I append on one of the IDs at the end, and use the get method here, it now just returns a single item. So with no parameters, it gets all. And with an ID parameter, it fetches just that one. And again, we can see our 200 response here, our 200 OK response. So we can test out the other methods here as well. Let's say I want to delete this to-do. I'll change my method from get to delete. I'll see if I can delete ID 9. It says my delete worked. And now I'll go and try and query it again. If I do get to-dos 9, I guess it doesn't actually delete from the database. That's okay. So just install Postman for now. You can play around in Postman with this kind of mock API. So you can see it's got 6 different resources: post, comment, albums, photos, to-do, users. And we can see the different REST verbs or REST methods. So get posts will get all. Get posts with an ID will fetch that one. Get post 1 comments will get all of the child comments attached to post 1. Post, put and delete, so they're not actually functional because they don't want us modifying the data set. But you can see these are starting to look familiar. Patch and put are actually the same thing. They're used for updating. Okay, it's 10 to 12, so just please make sure you've installed Postman. We will take a break here. We haven't written any code, so I'm not going to push anything onto GitHub. When we come back, we're going to create two different versions of an API controller. And then we're going to look at a cool tool called Swagger. And what Swagger does is Swagger will actually write an API document for us. We're going to create an API so that other developers of other applications can use it. We need documentation, just like we read the Stripe documentation, or here Spotify defines all the methods in their API and how to send the requests and what we get back. So Swagger will let us build an API, and then it will actually write the documentation for us. So it'll give us something like this: a list of all the methods, all the endpoints, and how to use each method. Okay. So we will take a break here, and we'll come back at just after 12. Let's all get up and stretch our legs. Let's get out of our chairs for 10 minutes. We'll be back in 10.